We like to think sleep is simple. You lie down, you turn off, you wake up. But underneath that quiet shh, your brain is running a night shift full of safety locks, emergency systems, and the occasional glitch. You wake up, but your body doesn't. You drift off and your body panics. You think you're awake, but your brain is still booting up. And sometimes you're conscious except for the part of your brain that isn't. These aren't failures, they're ancient survival systems, running on instincts older than you are. While you sleep, your brain isn't resting, it's acting on its own logic, almost like it has a mind of its own. This is what your brain does to you while you're asleep. Microsleeps. If I close one eye, that's still technically half awake. Gonna rest for a little bit.
Huh?
Nothing out of ordinary. Another peaceful night. Crime, not on my watch. So the guard is having microsleeps, a tiny involuntary nap your brain sneaks in when it's had enough of it. They usually last from half a second to a few seconds. Doesn't sound like much, but if you're protecting the most valuable painting in the world or behind the wheel of a car, those 3 seconds are enough to recreate a scene straight out of Final Destination, starring you. When you stay awake too long, two forces collide. First is the sleep homeostat, a biological timer that tracks how long you've been awake. The longer you're up, the more a molecule called adenosine builds up in your brain. Adenosine acts like a pressure signal, binding to receptors and telling neurons to slow down. That's why caffeine helps. It blocks adenosine receptors. But the chemical still accumulates. You're just masking the pressure, not deleting it. The second force is the circadian rhythm, run by neurons in the suprachiasmatic nucleus of the hypothalamus. This rhythm sets daily highs and lows in alertness. When sleep pressure is high and circadian alertness is dipping, late night, early morning, mid-afternoon, the brain runs out of fuel to keep every circuit online. So here's the glitch. Instead of all or nothing sleep, the brain can go local. Neuroscientists have found that during sleep deprivation, parts of the cortex show slow wave activity, the same kind of rhythm seen in deep sleep, while other areas remain in waking mode. So you can have islands of sleep in a sea of wakefulness. If those islands land in the visual cortex, you stop processing what's in front of you. If they land in motor regions, your reaction times collapse. Physiologically, microsleeps look like drooping eyelids, long blinks, eyes rolling, or staring blankly with no actual perception. Even when the eyes stay open, the thalamus starts blocking sensory input. This is called thalamic gating. It means the signal from your eyes never fully reaches the cortex. So you're looking at the road, but nothing's being recorded upstairs. Evolutionary biologists point out that this makes sense. Many animals split sleep into fragments. Birds can nap mid-flight. Dolphins literally shut down half their brain at a time. Humans likely inherited the ability for short, partial shutdowns to protect against exhaustion without full collapse. In the ancestral environment, missing a few seconds while resting by the fire wasn't catastrophic. In a modern world of freeways and heavy machinery, it's lethal. The only fix is actual sleep. Caffeine can block adenosine for a while, bright light can nudge the circadian system, movement and novelty can wake up dopamine, but none of these erase the pressure. Microsleeps are the brain's emergency safety valve, short bursts of offline time to survive the overload. Ignore them long enough, and the brain stops asking politely. It drags you under. But sometimes you wake up and your brain's just in the corner going googaloo googaloo googaloo. Sleep inertia. This groggy, can barely walk straight feeling, that's sleep inertia. Basically, leftover dream sludge leaking into your awake time. Your eyes are open, but half your brain is still snoring. Reaction times tank, memory goes fuzzy, and decision-making takes the morning off. That's why grabbing your phone half asleep is a disaster. You'll either text your boss or order 300 Labubus. When you're in deep sleep, the brain cells are firing in these big, slow delta waves. That helps clear out waste, restore energy, and reset connections. But if your alarm yanks you out mid-wave, the system doesn't switch off instantly. Blood flow and glucose use in the thinking parts of your brain, the prefrontal cortex, take time to climb back up. So your eyes are seeing the room, but your frontal lobes, the part that handles memory and planning, are still booting up. That's the fog. That's why shift workers often feel like zombies. Sleep deprivation makes it harsher too. Your brain dives harder into deep sleep to catch up, which means when the alarm goes off, it's more likely to yank you out of the deepest stage. That's why a 20-minute nap can feel refreshing, as it usually keeps you in the lighter stages of sleep. Those stages refresh you a bit, clearing adenosine, the sleepiness chemical, improving alertness, but they don't pull you so deep that waking up feels brutal. That's why you can pop back up feeling clearer, but a 2-hour nap, on the other hand, often drops you into deep, slow-wave sleep. If the alarm wakes you during that stage, your brain's still running on those big, slow delta waves. You get sleep inertia when you wake up from that stage. This fog doesn't last forever. Light exposure shuts down melatonin, movement kicks your nervous system into gear, and stress hormones like cortisol naturally rise in the morning to push you into full wakefulness. Give it 30 minutes and you'll feel mostly human again. Until then, sleep inertia is just the price your body pays for having a deep, useful sleep system that doesn't care about your alarm clock. And just when your brain does figure out how to rest properly, wait till you wake up, wide awake, and realize your body didn't get the signal. Sleep paralysis. So you're out cold, dreaming you're soaring across the Quidditch pitch, quaffle tucked under your arm, and 2 chasers are hot on your tail. The goalposts are right there, you're about to score. When a Dementor glides right out by the rings, you jolt in terror and your eyes snap open. You're awake, at least your brain thinks you're awake, but your body? Nope. Arms won't budge, legs are concrete, throat's clamped tighter. And there in the corner, moving closer and closer, is that same Dementor sliding through your room. That's sleep paralysis. It feels like a curse, but it's actually part of the built-in sleep machinery. This happens because of how your brain handles REM sleep. That's the stage where the most vivid dreams occur. In REM, your brain is buzzing with activity, but your body is deliberately paralyzed. The part of your brainstem called the pons sends inhibitory signals down the spinal cord which block motor neurons from firing. So this is like a built-in safety lock, so you don't act out dreams. Because when you dream of the Quidditch World Cup, you don't want to be swinging kicking your bedside lamp. The glitch happens when your brain wakes up before the pons release the muscle lock. Now you've got a mismatch. Awareness online, body offline. So when you wake mid-REM, your sensory cortex is mixing 2 signals. Real inputs from your room plus leftover dream fragments. The thalamus is letting both through. The result? You see shadow shift, you hear whispers, you feel a crushing weight on your chest. It's your brain trying to explain the mismatch. The fear center in your brain is firing full blast, so instead of calmly accepting, oh, I'm paralyzed for a sec, it goes, nope, must be a Dementor. This chest pressure is real physiology too. During REM, the diaphragm still works, but other breathing muscles are suppressed, so breathing feels shallow and heavy. The brain interprets this as something external pressing down. Across cultures, people have explained this the same way. Japanese kanashibari, a demon holding you, Old English mare, hence nightmare, African legends of witches stealing your breath, all based on the same neurological glitch. From an evolutionary perspective, sleep paralysis is ancient. We see versions of it in almost all mammals and even birds. For our primate ancestors, it was essential. Sleeping in trees at night, you couldn't risk flailing around while dreaming and plummeting to your death. Paralysis was a survival feature. Waking up while still paralyzed, that's just collateral damage, rare enough that natural selection never cared. And just when you think it's all over and you can finally rest, the body decides to throw itself off a cliff for fun. Hypnic Jerks. Chicken or beef?
Huh?
Guess that free-range chicken now. Right as you are nodding off, your body is trying to hand over control. The systems that keep you upright and alert all day are being switched off, and the ones that handle sleep are booting up. Most nights this handoff is smooth, but sometimes the body misreads the signals. You are lying down on the beach in the middle of a flight? Bro, I'm just relaxing. Relaxing means falling. Engage laser defense. Muscles suddenly relax, and your balance system interprets that as we're falling. The fix? A big sudden jolt to make sure you don't crash, and that's Hypnic Jerk. From the evolutionary side, this glitch makes sense. Our primate ancestors often slept in trees. A sudden drop in muscle tone during early sleep could mean losing grip. A reflex twitch would re-engage the muscles, potentially saving you from a 20-foot plunge into a leopard's mouth. Today, we're not dangling from branches, but the ancient reflex still fires. Evolution doesn't rewrite old code unless it's lethal. Same as now. If the code works, don't touch it. We can ignore small glitches. They're more common when you're sleep-deprived, stressed, or hopped up on caffeine. Your nervous system is twitchy, firing off mixed signals, and the result is more false alarms. The reflex itself is harmless, just a quick surge in heart rate and muscle activity, then everything settles. But in that instant, it feels like your whole body staged a mutiny. Every twitch, freeze, or half dream is just evolution doing its best impression of a software update. It's messy, it's old code, but it's kept us alive this long. And that's all for today. Thanks for watching.